This is NASA TV.
Good afternoon. Thank you for joining us here on NASA TV. We're about to conduct a briefing right after the flight readiness review of the return of Bob Behnken and Doug Hurley to planet Earth, completing the SpaceX Demo 2 mission and the first test flight of the crewed commercial vehicle. I'm joined by an esteemed set of panelists here from across the country to discuss what came out of the flight readiness review, as well as from what's to come, both from NASA and from SpaceX. Joining us today for this briefing is NASA Administrator Jim Bridenstine. Here in Houston, Texas, we have Steve Stitch, manager of NASA's Commercial Crew Program, and Joel Montalbano, the manager of the International Space Station Program. And then all the way from SpaceX, Benji Reed joining us, Director of Crew Mission Management. Thanks to our esteemed panelists for joining us today. We're going to be opening up with some comments from each of our panelists before getting to questions, taking questions from our phone bridge. Make sure you call in. To submit a question, make sure you dial *1, and we'll be able to address them right after comments from our panelists. We're going to start our comments first from NASA Administrator Jim Bridenstine. Administrator Bridenstine, take it away.
Well, thank you so much, Gary. As you just mentioned, the return flight readiness review is complete, and the teams, the NASA team and the SpaceX team, everybody remains go for return, and we cannot wait to get Bob Behnken and Doug Hurley back to Earth. But of course, we have some weather pending, and so just like when we launched, we had some challenges with weather. We may have that again, but the first opportunity remains August 2nd, and we look forward to seeing if that's going to be within the realm of what is possible. A couple of things that are important. I'm here at the Kennedy Space Center right now. Tomorrow, we're launching a mission to Mars, the Mars 2020 vehicle with the Perseverance rover inside and Ingenuity, a helicopter that is attached to the rover. So we have a lot of things happening right here at the Kennedy Space Center. We're excited about that launch tomorrow morning. And of course, while we were doing the press conference for the Mars launch, we had a barge pull into the bay here, and the barge, of course, had a stage adapter for the SLS rocket, which, of course, is going to launch Artemis 1, an uncrewed Orion capsule around the moon next year. So many great things happening here at NASA. I want to say thank you to the SpaceX team and, of course, to the NASA team for making Demo 2 possible. It is not over yet. Entry, descent, and landing is ahead of us. But certainly we're very excited to get Bob and Doug back home and get on to Crew 1 and Crew
Team. As Jim said, we had our flight readiness review this morning for landing. We really took the time to review the vehicle on orbit. You know, it's been on orbit for about 63 days. We talked pre-flight about having the capability to go 120 days. The systems on Dragon are doing very well. The spacecraft is very healthy. We went through all the systems, any issues or problems that we saw on orbit in terms of how the vehicle responded to the thermal environment and the different parts of space. We reviewed the readiness of the ops teams and also the recovery teams. And so we came out of the FR with a go to proceed toward undock, deorbit, and landing. Today, I'll talk a little bit about the landing operation and kind of how things will unfold over the next few days, and a little bit about decision making. If we could show the graphic first, we have 7 landing sites that we're going to be using, as Jim said, for the landing as early as Sunday. You can see these sites. They're spread across Florida, Pensacola, Panama City, Tallahassee, and Tampa. Those are Pensacola was there before, but we added the new sites of Panama City, Tallahassee, and Tampa since the initial flight readiness review, and then Jacksonville, Daytona, and the Cape on the eastern coast of Florida. We added the Daytona site after the flight readiness review and did a bunch of work between NASA and SpaceX to ensure that site was ready. Over the next few days, we'll be carefully looking at the weather and getting ready for the undock and deorbit and landing. Just a little bit of the sequence for the earliest opportunity would be to undock on Saturday. The crew would wake up about 7:30 Central Time here in Houston. We would close the hatches about 4:30 on Saturday and undock around 6:35 p.m. Central. And we have about an hour or so undock window. And then that would set us up for our first landing opportunity on Sunday, deorbiting around 12:56 Central Time on Sunday, and then landing at about 1:48 p.m. Central. We're going to watch the weather very carefully. You know, we have a series of sites and many days in the future. If we don't undock on Saturday to come home on Sunday, we would move that undocking to Monday. So we'll watch this tropical storm that's probably going to form. It's a tropical area of disturbed weather right now. Looks like it may be coming into the Florida area. And we'll kind of take it day by day. We have decision points and weather briefings at about 24 hours prior to undock. Then at around 6 hours prior to undock, when we start to bring some cargo over from the space station, and then 2.5 hours prior to undock. So we'll have to evaluate the weather each day and just see how things unfold. As Jim said, you know, this is a test flight, and we're going to take our time to come home. We have plenty of opportunities here in August, and we're in no hurry to come home. We've completed all the objectives really for the mission while we were docked. We figured out if 4 crew could live in Dragon, habitability demo. We completed all those objectives while docked, and so now is the right time to bring this vehicle back and then start the processing of this vehicle, which will go forward and fly again in the spring on Crew 2. And then finally, when we land, you know, the important thing after landing will be to review all the data from this flight. So the importance of getting the vehicle back, getting Bob and Doug safely back, is to then go assess the data on this flight. That sets us up for the Crew 1 mission as early as the end of September. And we'll go through the data methodically for that flight and make sure we're ready to start the operational flights. And with that, I'll turn it back over to you, Gary.
Thank you, Steve. I'll now hand it over to International Space Station Program Manager Joe Montalbano.
Thank you, Gary. Well, hello again, and welcome to the SpaceX return post-flight readiness review briefing. We had, as you heard, a great review today. We walked out of the review with no actions and just standard open work. So the team has done a tremendous amount of work. You can tell by what you heard today, and the team is ready to go. I mean, it's been great to have Bob and Doug on board, and they complemented the crew that came up on Soyuz in April. The fact that we were able to complete 4 EVAs and a tremendous amount of utilization, research, technology development. We worked cargo operations with the Japanese transfer vehicle. We had medical operations. I mean, these guys have just complemented significantly to the ISS team and to the ISS program and to NASA in general. You know, the work we're doing on board space station, the utilization, the research, the technology development, the work that's being done to help us for, you know, to go past low Earth orbit and help us with the Artemis program. It's just been outstanding. And the fact that we had 2 crew today is just a little view into the future. Eventually we'll have 4 crew on the Boeing and SpaceX missions and increasing our science and research to about 70 hours a week of utilization, research, technology development. So we're just looking forward to that. I'll also remind you that this year we celebrate 20 years of continuous human presence on board the International Space Station. So with that, we look forward to the return of the SpaceX vehicle, Doug and Bob. And with that, I'll hand that back over to you, Gary. Thank you.
Thank you, Joel. Now for some final comments from Benji Reed over at SpaceX.
Really sincere thank you on behalf of all of the SpaceX employees, our vendors and contractors, all of our team that works together to NASA, and of course to Bob and Doug and to their families for allowing us the opportunity to return human spaceflight to the United States. As mentioned earlier, I think the administrator mentioned entry, descent, and landing, as we call it, EDL. Bringing a spaceship home, that's a really big deal, and it's very important. It's part of that sacred honor that we have for ensuring that we bring Bob and Doug back home to their families, to their kids, and making sure that they're safe. So we give it the same attention as a team, both as SpaceX and a joint team with NASA. We give it that attention and that concern that we would for any launch. and we're very much looking forward to doing this. It'll be the first time in, I think, about 45 years that we have splashed down astronauts from space. So this will be another historic and great moment for the nation. So I think the next thing I'd like to do is actually show a little video we have talking about the mission so far.
Good morning. Welcome aboard. Stand by for umbilical comm check.
SpaceX Dragon, we're go for launch. Let's light this candle.
3, 2, 1. Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA. Go SpaceX. Godspeed. Bob and Doug.
On behalf of the entire launch team, thanks for flying the Falcon 9 today. We hope you enjoyed the ride and wish you a great mission.
We would like to welcome you aboard Capsule Endeavour. We do have a friend on board with us, Trimmer, the Apatosaurus.
I get goosebumps every time I see that, and I can only imagine what it's going to feel like when we bring those guys back home and they get to see their spouses and their kids. It's going to be amazing. As mentioned, I think everybody's talked about it. We had a successful flight readiness review for undock today with NASA, an agency level review that went well, as we proceed into things, we'll be evaluating the weather. So kind of over the next 24 to 48 hours, we'll be looking at the weather, ensuring that we're really ready. We'll be doing that closely with NASA. Not only do we do these checkpoints, but there'll be a continuous monitoring process to ensure that we know that we've got safe weather to bring them home in, safe weather to splash down, and of course do the recovery operations and bring it back to land. As part of that, I think we have a little infographic that we can put up right now, and I'll just talk through a couple of items on that. So you can see in this graphic, and this is one of the great graphics that are available online as well to check out. But the first step that happens is you do a departure burn. Actually, I'm sorry, you do an undock, automated undock, autonomous undock from station. Just like how we did the autonomous docking and undocking for Demo 1. We'll do the same thing, do an autonomous undocking for Demo 2 for this mission. Then there's a departure burn, and then we move into the phasing burns. So depending exactly on the launch, or the landing site, I should say, and the timing of everything, it depends on how many orbits we need to do, what the number of phasing burns are, and the timing of those. So that sequence really depends on ultimately where our landing sites will be and our landing timing. Once we're ready to actually come home, the next step is a trunk jettison. And then the deorbit burn, and that deorbit burn lasts a number of minutes. It's actually one of the longest burns in the whole mission. And then we re-enter, and re-entry. There's the heat shield on Dragon. We've used this, built up on our technology that we've used for many of the missions on CRS, and of course on the Demo 1 mission we demonstrated on this Dragon 2 capsule. Because you get a lot of heating as you come in, and it's really critical that we keep the crew and the vehicle safe from that heating. The heat shield and all of the thermal protection system that's all around Dragon will keep them safe. We'll re-enter, and then the drogue parachutes will deploy, and then the main parachutes deploy, and then we splash down. After splashdown, we have the SpaceX recovery forces. I like to think of them as the SpaceX Navy. They get to go in and recover the crew. A couple of fast boats will go out, ensure that everything is ready to go, that the vehicle is safe to approach, checking for any of the hypergolic fuels, making sure there's no leaks. Everything looks ready to go, and the other fast boat is there as a backup, and also doing parachute recovery. Once the fast boat gives the clear, then the main recovery vessel moves in, and we'll lift the capsule up onto the deck of the boat into a nest, and then help Bob and Doug come out of the capsule and check them out and make sure that they're okay. Once we have them on board the vessel, we'll take the time to, like I said, check them out, and then within about 4 hours or less, we should have them back to land. And just depending on landing location and needs, we have the ability to bring them back very quickly via helicopter or come back on boat. Either way. That really is kind of the whole process of the recovery. Ultimately, they get to, once they get back to land and they get checked out there, they get to see their families. This whole process, of course, is a test mission, and as we do this, we're again giving it all the same attention that we would for every crew mission, and that also extra attention we do to as we observe all of the data and observe everything that's happening. This is really critical. Obviously, I mentioned that to date the mission's looking beautiful. It's very clean. The data's looked great, but we want to watch all of this data and learn from it as we come back now. What we'll do next, after Bob and Doug we've gotten Bob and Doug safely home, is we'll start to look into the vehicle. We'll open it up, check it out, make sure that everything looks great, gather a lot of data that way. We'll also have downloaded all the data that's recorded on the vehicle, and then start the process immediately after splashdown of assessing and analyzing all of that data and making sure that we're ready to go. As Steve Stitch mentioned, once this happens, once we feel really good about everything that happened on this demonstration mission, this test mission, we wrap up the certification process overall for the program, and then we move on into operational space, which, as Joel mentioned, is really the key. That's when we're sending up 4 crew members every time in every mission, and we've got that next mission coming up really soon, and that'll be in late September. Crew 1 is what we call it. And I think we actually have a picture of that vehicle ready to go, just about. Let's take a look at that. There it is. You can see that. It's in the clean room right here in Hawthorne, actually just a few feet away from me. And we look forward to getting that capsule ready to go, and it'll be shipping out of here in just the first or second week of August. So coming up very soon. That'll be ready to go, and then it'll finish final preparations down at the Cape. And, of course, I mentioned there's 4 crew members, and I think we have an image of the 4 crew members. And there they are, Shannon and Victor and Mike and Soichi from the JAXA Space Agency. We're very excited to have this crew getting ready to go. They've been going through their training, wrapping up their final training. They're actually here in the building right now doing some of their final work with us today and this week. And I mentioned Soichi is super exciting because it'll be our first time we have an international partner on board representing Japan and the JAXA Space Agency. So super cool to have that coming online. And once we go from this group, then we'll be moving on to Crew 2, which we're going to be ready to fly just 6 months later. As Steve Stitch mentioned, Crew 2 will actually be flying on the same vehicle that Bob and Doug are coming back home. That will be a refurbished vehicle. We'll be putting that through reuse, and look forward to that mission as well. Again, I just want to say thank you to NASA, to the nation, to the American public, to all the international partners, and just to everybody who's put all of their heart and soul and time into this. We got the next big step to go to bring those guys home, and we're looking forward to making it happen. Thank you.
Thank you, Benji, and thank you to all of our panelists for those initial comments. We're now going to open it up for questions. Now, we have a lot of them, but if you don't, if you need to submit a question, just make sure you press *1. There's a lot of questions that we have to go through, as well as some of those initial comments. So if you find that your question has already been answered, just make sure to press *2 to address it. As I said, we do have a lot of questions to get through today in a limited time, so I do ask that you refrain to just one question. So we'll start it off with Lauren Grush from The Verge. Lauren.
Hi, thank you so much for taking my question. I'm curious about how much leeway you have when performing all the various maneuvers for leaving. So, for instance, what's the last possible moment before Crew Dragon's undocking where you can decide to call off the return and reschedule for another day? Also, how much leeway do you have to perform the deorbit burn in case conditions drastically change at the landing location? Thank you.
I'll take that one, Lauren. So for undock, really we have quite a bit of margin in terms of that decision process. As I said earlier, we really are trying to look at about 6 hours prior to undock if things are really lining up to be good to undock. And then another decision point a little closer in at 2.5 hours. That's really to prepare the vehicle and take a lot of the cargo in. There's a couple of freezers that are bringing home important science that we want to put in the vehicle. But literally we have about an hour period where we could undock, and if at the last minute we thought that the weather or something wasn't okay, the SpaceX team could command the vehicle and Bob or Doug could stop the whole undock sequence. And so the whole beauty of this sequence is that we can stay on station for a period of time and not get into free flight, and then save our opportunities. It's the same thing relative to the whole deorbit sequence after we've undocked and we're heading to our landing opportunity. And most of those are about, let's say, 15 to 17 hours after undock. We can then stop and pause before we execute that deorbit burn, and then go around again. Most of the wave off opportunities would be about 48 hours later, and we have roughly 3 days of consumables once we undock to try to bring the vehicle home.
Thank you for your question. We'll now move on to the next. Paul Brinkman from UPI. Paul.
Yeah, thanks for taking my question. I would really like to hear some more detail about the capsule tests during the flight and when attached to the space station. What was learned, especially what was learned during the habitability demonstration.
Yeah, I could take that one. So we did a habitability test, and really the purpose of that, this flight has 2 crew members on board, and so Bob and Doug had the opportunity to live in Dragon for the first part of the flight for about 20 hours or so. So that habitability test was really looking at this next flight that Benji talked about with our next crew 1. We'll have 4 people on board Dragon. And so what we did is we brought over additional crew members and had them in Dragon, and then we did a series of life in the day of Dragon. How would you prepare meals, different hygiene activities, how would you sleep in the seats, and tried to assess that and tried to learn from this vehicle for the next vehicle. And those tests went really well. There's a few things we're learning about how to package and how to stow various things for the crew to get to when they need them on orbit. But it was very successful, and so we take that data from that habitability assessment, we feed it back into Crew 1, and we'll make that flight even better for that crew. So.
Next we have Stephen Clark from Spaceflight Now. Stephen.
Thank you for taking my question. I'm curious, maybe Benji can talk about what happens with the spacecraft once it's back on Earth. Does it come back to Cape Canaveral on the recovery ship, or does it come back by land? And can you talk about the inspections, refurbishment, and some of the modifications you're going to be making on the spacecraft to upgrade it for a full 6-month crew rotation mission next year? Thanks.
Sure, absolutely. That's a great question. So, as I mentioned, once after splashdown, we bring the vehicle up onto the deck of the recovery vessel. We get Bob and Doug out and focus on them. And at the same time, there's actually a refurbishment crew and a vehicle checkout crew that's on the recovery vessel at the same time. So at the same time that we're pulling Bob and Doug out, we're inspecting the vehicle, we're safing it in a number of ways. We're already starting to pull data off of the data recorders that are on that vehicle at that time, and starting a number of processes. In fact, we're equipped to be able to start the refurbishment process entirely while we're on vessel as we're coming back into port, depending on the landing location and how long it takes for us to get back. Since we are landing on the East Coast, and this is part of the reason that we're landing on the East Coast, is to bring us closer to where we're going to do refurbishment and be ready for launch. So we have an awesome Dragon facility down there for not only doing the initial pre-launch preps when a Dragon arrives from Hawthorne, but also to do full refurbishment of Dragons, just like we do refurbishment of Falcons, and basically do the whole processing and be ready just to put a Dragon right back up on top of a Falcon and get ready to launch. Some of what that looks like in this case is we'll actually be taking off a lot of the panels of Dragon. We'll be inspecting inside. Again, as a test mission, we want to make sure that we kind of dig deep and understand everything that happens that's gone on with this vehicle, make sure we're really ready to go. And then do some of the aspects of the refurbishment. There are some things that we will replace, some things that are standardly replaced, some things that we want to upgrade based on lessons learned or that were already planned in the work. And of course, there's the trunk itself. Since the trunk is jettisoned before re-entry, we have to produce a new trunk for each flight. And so in this case, for example, we'll have upgraded solar panels, solar arrays on the trunk for the upcoming flight. So it's one of the examples of things that will be upgraded. The whole process is actually very fast. We should be able to have Dragon refurbished and ready to go in just a matter of a few months, and have plenty of margin, multiple months of margin against 6-month reflights. So we can take a vehicle and be ready to fly it again 6 months later with multiple months of margin. So that's actually very exciting. And again, almost entirely reused. A lot of the vehicle is almost all of it is totally reused. Like I said, a few things that we fix up or that we might replace or we decide to upgrade. That's really it.
Next we have Joey Roulette from Reuters. Joey.
Hey, thanks so much for doing this. Question for Benji Reed. Originally, SpaceX was planning to use new vehicles for each PCM mission. I was wondering what led to the decision to reuse Crew Dragon for Crew 2, and how the refurbishment process for that is going to be different than originally planned. Thanks.
Sure, absolutely. You're right. Originally, on the contract, we decided to go for new vehicle use. But as we've continued down in the last number of years of proving the awesomeness of reuse and reflight, the importance of it, not only from an economics viewpoint, for overall for the spaceflight industry, but also from a safety and reliability perspective. You learn so much from a vehicle that you can refly, and you also have to build it better, and you have to build it more robustly for a vehicle that you know that you need to use multiple times. So the reality is that Dragon 2, this line of Dragons, which will be used for both the crew vehicles and the cargo vehicles, Dragon 2 is designed for at least 5 reuses. And possibly even more. So from the get-go, we were expecting to be able to reuse this vehicle. We had always hoped that we'd be able to reuse it on NASA astronaut missions. We had also planned, though, from the beginning that we would be able to reuse it for commercial passenger missions and any other uses. So the good news is that we were always ready to do it, and it was always part of the plan. We've been working closely with NASA over the last few years, and then recently to finally kind of lay out the whole plan of what reuse would look like on Crew. We want to make sure, of course, that that's just as safe and just as reliable. In fact, I think it's even more safe and more reliable in a lot of ways. And we've been working closely with NASA to lay out what that plan looks like and what that certification process is. So while we're in the middle of refurbishing this Dragon, getting it ready to go for Crew 2, we're also wrapping up the certification process for reflight. So that's very exciting. Not a lot of difference in what we'd originally planned for this vehicle, but a lot of difference in what it took to refurbish a Dragon 1. The Dragon 1 capsule took longer to refurbish, although we got very good at it. Out of the 20 missions that we flew, almost half of those, I think 9, were flight proven. And so we learned a lot in that effort to go from also what was originally a new vehicle every time to reuse vehicles, reflight vehicles, what it took to refurbish them. And we applied all of that knowledge to the Dragon 2 line.
Next up is Tariq Malik from Space.com.
Hello, thank you very much. Tariq Malik with Space.com. And my question, I think, is for Steve Stitch, or Benji. I'm really curious about what your weather constraints are when you're picking one of the 7 landing sites that you're going to target either prior to undocking. I know that there's a tropical storm approaching for Sunday, and I'm wondering kind of what are you looking for to make sure that you're comfortable with one of those 7 landing spots, and when is that cutoff to have to pick it before you can undock? Thank you.
Yeah, I can talk a little bit about the weather constraints that we'll be evaluating. The first one, and probably the one that may be the most challenging, is wind. The wind speed can't be any greater than 15 feet per second, or about 10 miles an hour. So this is to protect how the vehicle actually lands in the water, and how the water will come up and surround the vehicle at touchdown. The next criteria is really waves. So there's a certain amount of wave height and wave period that we have to have within limits, and that really has to do with, again, as the heat shield impacts the water, protecting that from a structural capability. We don't want any rain within the area. We don't want the parachutes of the vehicle to get rained on, or any lightning. And then we have also some criteria. As Benji said, depending on the landing site, the way that the crew gets back to shore actually is via helicopter. And there's some criteria also for having the helicopter be able to land on the ship, in terms of the motion of the deck in the water, and then obviously visibility and things like that for the helicopter. So those are the constraints. And again, what we really are trying to do is set ourselves up to have these constraints be met prior to undock at 2 sites. So we're really looking for 2 sites to be for undock. And then we can take that down to the wire relative to undock. And of course, we can also decide, if the weather is looking bad, that, hey, we're not even going to try to undock that day. If really, if this hurricane, tropical cyclone moves in and to the area and really has bad weather across multiple sites for multiple days, then the beauty of this vehicle is we can stay docked to the space station. We've worked with Kenny Todd and Joel Montalbano, and they understand it's a test flight and it may take a little while to get off. We'll just stay there and we'll wait for the weather to clear. So.
Okay, next we have Eric Berger from Ars Technica.
Yeah, hi, good afternoon, and good luck, everyone. Question for Jim, maybe following up on the question Joey asked about reuse. Can you talk a little bit about how NASA has quickly, it seems like, become more comfortable with reusing both the Falcon 9 rocket and the Crew Dragon spacecraft? Thanks.
From my perspective, what we're really looking for in all of our missions is sustainability, and that's true for low Earth orbit. It's true now when we go to the moon. We're looking for how can we drive sustainability, reduce costs across all of our missions. So when we think about, for example, and you know this, Eric, when we think about the Gateway, for example, I refer to it as not a space station in orbit around the moon, but as a reusable command module that will be there for 15 years to be used over and over and over again. And we want our landers that go back and forth to the surface of the moon to also be reusable and refuelable. So really what we have learned through this whole process, and of course the Commercial Crew Program has kind of proven this out, is that with reuse we can actually drive down costs and we can increase access. And of course all of this was developed because NASA did the right thing and established basically the high-level criteria, the requirements, and didn't get involved in designing everything downstream. But we set the high-level criteria, and that was, in terms of payload and safety. And then we let private companies go and innovate. And that innovation ultimately drove us to a point where we're now reusing these rockets, reusing the capsules, and of course we want to apply that to what we do at the moon and eventually Mars.
Next is Lavesio Alessandro from the SpaceX Reddit group. Lavesio.
Hello, thank you so much. This question is for Benji. What are the main reasons to deploy the trunk before the final deorbit burn, unlike what was happening, if I'm not wrong, with Dragon version 1? Thanks.
That's a great question. Fundamentally, that is the big difference. We're jettisoning the trunk before we deorbit, before we initiate the deorbit burn versus after. And a lot of it just has to do with general differences in the design of the vehicle. I don't have a lot of good detail to give you on that right now, but I'm sure we can get some of that for you.
Next is Gina Sinceri from ABC News.
Hi, Yes, you say 3 days of supplies. What are the limiting factors that would keep you from staying up longer before splashing down once you were undocked?
Yeah, I can take that. The supplies that we look at really are, oxygen for the crew to breathe, nitrogen, lithium hydroxide to scrub the carbon dioxide from the air, and then simply put, food and water. And when you lay all those things together, it turns out, water and lithium hydroxide, the chemical that scrubs the CO2, are about the limiting consumables. So it kind of puts you at about 3 days of capability. If we had to, we could probably stretch that a little bit more, but going in, that's kind of our number for planning. And so it's pretty typical for any time that we're undocking a vehicle from the space station. You have some time that you have before you can get to the ground. The vehicle will have plenty of power, plenty of propellant, plenty of oxygen for the crew. It really comes down to food, water, and LiO to scrub the CO2.
Next is Chris Davenport from the Washington Post.
Hey guys, thanks for taking the time. I wonder if you could just lay out for us what assets you'll have on standby in the case of an emergency, the C-17s, et cetera, and where they'll be stationed. Thanks.
Yeah, Chris, I can take that. So we do have several assets on standby. We are activating the Detachment 3 from the Department of Defense. We will have a C-17 stationed at Hickam in the event that we had some very strange, this is in Hawaii in the Pacific coast, and also on the east coast of the U.S. at Charleston. And so they'd be available for search and rescue for this test flight should we have some problem. We don't really intend to have that happen. We'll have the SpaceX vehicle go searcher and go navigator out, and one of those will be in the Gulf position for those sites, and one will be on the East Coast position for Jacksonville, Cape, and Daytona, and those will be the prime vehicles to go recover the crew. And then, of course, we've got helicopters that SpaceX has available to get the crew back to shore should we need that. So.
Next is Phil Harwood from CBS News.
Yeah, thanks, guys. For Benji, I think, Steve was telling us the vehicle is good to land in winds up to 10 knots. I'm wondering what the specifics are of wave height in period, what's allowed for this flight, and how will those numbers change for the Crew 1 vehicle? Thanks.
So that's a great question, and I'm going to look at my cheat sheet. And we've got some good things online, by the way. NASA's put out a great product that we've worked on with them as well. And it looks like we're looking for wave height, generally speaking, and wave period. We want to particularly make sure that we don't have any greater than 7 degrees of wave slope. It's really the important thing to understand about this is that it's an integrated problem. It's not only just one specific, like, oh, we have exactly this threshold for for winds, for wave, for all these different things. There are some absolute thresholds for some of these measurements that we're looking for that we don't want to go over. But in general, when we're assessing the readiness to bring them home bring home in a specific location, we're looking at an integrated combination of factors of the wind speed, of the wave height, of angle. All of these sorts of things are really important. And that's an important part of that. And then you asked a question about Crew 1 and how that changes. And we're actually we're going to have greater capability when we come to the Crew 1 vehicle. We'll be able to basically withstand even higher environments for landing, which will increase our landing opportunities as well. In combination with all of our supported landing sites, we'll have a really great a lot of opportunities to bring the crew home.
Thank you. And as Benji mentioned, we do have the specific criteria for landing available at nasa.gov. Work together with SpaceX on that. It's available there. Next, we'll move over to Marcia Dunn with Associated Press.
Yes, hello. For Benji, please. I'm interested in how many ships, helicopters, and how many people you're going to have staged for splashdown, and will you have equal numbers on both coasts simultaneously? Thank you.
Hi, Marcia. There's a backup and also goes out and gets the parachutes. In terms of number of people on the boats, it's over 40. I think it's 44 people are actually on the boat. 5 or so are contractors, the people who are driving the vehicle, the boat, and then there's about half and half, roughly 20 and 20 SpaceXers and NASA people on. That includes doctors and nurses and medical personnel. It includes the people I mentioned before who are doing safing and recovery and refurbishment of the Dragon vehicle. It includes, in the NASA group, of course, there are people who will be there ready to assist and support people from health and medical within NASA. When we start having international partners there'll be representatives from their space agencies as well as translators to help for any needs. So it's actually a pretty sizable group of folks that come out and help get ready for recovery.
All right, next is Marcia Smith from Space Policy Online.
Thanks so much for taking my question. It's for Steve and Benji. You've talked in the past about having about 6 weeks between the splashdown and then the launch of Crew 1 to complete the certification of the system. Since the mission is going so beautifully, as I think you said, Benji, is there a chance of accelerating that, especially if the splashdown gets delayed a little bit? Is it a 1-for-1 day delay from between splashdown and the next launch, or how does that work?
Yeah, I'll take that and then see if Benji has anything to add. Yeah, we've said in the past when we kind of looked at this timeline, post-landing, how long does it take to get the panels off the vehicle like Benji talked about, do the inspections, and then also get all the data from the vehicle, all the temperatures and pressures and accelerations. Going through that whole process leading to certification takes about 6 weeks. I wouldn't anticipate we would accelerate that at all if we landed early. We have talked about between NASA and SpaceX that if the landing were to slide a little bit to the right and we needed more time, we would just adjust that Crew 1 date just to make sure we have all the time. The important thing about this flight is it's a test flight. We actually have more instrumentation on this vehicle than other vehicles, and so we want to collect all that data, make sure we jointly analyze it between SpaceX and NASA, and then set us up for the next mission with 4 crew and to support the station needs for increment operations.
One more question. We'll pass it over to Dave Mosier from Business Insider.
Thank you so much for doing this and taking my question. Can you tell us about the on-orbit vehicle inspection results? I don't think I heard anyone discuss those. Did you detect anything anomalous, any signs of damage to the heat shield or other parts of the vehicle? Thank you.
I guess I'll take that. We did do an inspection over the weekend. We used the space station robotic arm to look at all the parts of the heat shield that we could see, and we do this for every vehicle that undocks. We do it for the Russian vehicles as well. We looked at that. We had a joint team between NASA and SpaceX. So we actually had 3 engineers from SpaceX here in Houston looking at all that data, and the results were very favorable. And there was no areas on the vehicle that were any concern for entry. We talked about that at the Dragon mission management team, and we talked about it at the FRR today. And the vehicle's safe to return. And we'll do the same thing for Crew 1 and subsequent flights. This was really a test out of that system as well. It worked great, and we were able to get the data we needed, really good resolution photos, and clear the thermal protection system for entry.
All right, with that, we'll wrap today's briefing. Thanks to all of our panelists for joining us today and answering questions, and thank you for submitting those questions. We still have a lot of milestones coming up. You can go to nasa.gov to reference this at any time. Of course, we have Perseverance launch tomorrow. The crew aboard the International Space Station will be conducting a crew news conference at 10:45 a.m. Eastern Time. And then, of course, we'll continue to look for that weather. But right now, we'll go for 9:10 a.m. Eastern Time to do a farewell ceremony aboard the International Space Station on Saturday, August 1st. And then again, watching that weather, we'll be going live for the undocking broadcast at 5:15 p.m. Eastern Time. Thanks again for joining us. Godspeed, Bob and Doug.